Atomic composability is the end game in blockchain.
Synchronous atomic composability is essentially an end game.
In this episode, Ankit and Igra Labs team are discussing why hundreds of millions are being poured into trying to solve atomic composability. The second half of the video is centered around a highly anticipated Igra's testnet, Caravel.
People are waiting for testnet.
It's crazy, but it's a good crazy.
You will learn how Igra Labs team is thinking about L2 security with their upcoming nodes and building a trustless L2 environment on Kaspa.
Decentralization and censorship resistance can be guaranteed only if community around our nodes.
With this content, our mission is to bring atomic composability to the forefront of Kaspa community. But in no means this episode provides complete answers.
But Yoni's vision, is bigger than technology.
I'm here with Pavel and Denis from Igra Labs. How are you both?
I'm fine, thanks. Thanks for having us.
Awesome. Guys, I wanted to have you over to discuss atomic composability, a topic we didn't get into on our last episode, along with the latest updates from Igra Labs. So let's quickly go over atomic composability, and then we can later, second half of the video, we can discuss the updates from Igra. So let me quickly ask you guys, it's such a buzzword in the blockchain industry. What is atomic composability and why is such a hot topic in the blockchain industry?
Where do we start exactly? It's impossible to explain even basics of this. Like we can touch fundamentals, definitely. You're completely right saying that it's a very hot topic currently in programmable blockchains, especially in Ethereum ecosystem, because it's still most developed.
I guess the way I think about it myself, right? I think I can break down atomic and composability. Like these are two terms that comes from computer science, right? So those terms are fine. I think we can define them. But as a whole, I think it's, all or nothing. The way I think about atomic composability, right? A very simple way to put it. Either all things get executed or none get executed, right? Like that's the example I think about it.
It's really easy if you are familiar with Ethereum, because original Ethereum, yes, where all the smart contracts are executed by the base layer, right? The Ethereum proper is naturally atomically composable. All the transactions there are atomically composable, right? One smart contract in one transaction, you can call several smart contracts. Okay, and they either work together or they fail together. Okay, there's no in between. There is no state transition of Ethereum happens if any of these calls in this transaction in any smart contract will fail. Okay, so this allows, for example, if you take a flash loan. Yes, in one transaction, execute some transaction, return the loan, and if the transaction doesn't work, your loan didn't happen. Okay, so that's a beautiful. And what's the problem now is that Ethereum went towards roll-up-centric architecture. Okay, lots of activity went to rollups. Okay, and because they have each one has their own consensus, their own sequencing. This system broke, okay? But a contract on Arbitrum cannot atomically call a contract on Optimism, for example, okay? And this creates a problem, okay? And Kaspa, they are proposed.
Before we going into Kaspa, we forgot one very important word which should be said: synchronous, and asynchronous.
Right.
There is also
This is what I mean. Like
things.
It's
I like it, guys. Carry on, please.
There are different.
So basically, in what I explained. Okay, now if your smart contract live on Ethereum in different rollups, they can only interact asynchronously. Okay, not in the space of the same transaction. There will be several transactions. Okay, for this interaction, and this is called asynchronous interaction. Okay, because it's not in.
It's not have.
Let me make it a little bit more precise. You can have asynchronous atomic composability on Ethereum today.
Yeah.
Because that's you have a block time of at least several minutes. It's not instantaneous. You cannot have the action between different contracts which will be implemented in atomic manner and also will be scalable, because you also have a gas limit, which limits your amount of transactions, amount of calls you can compose in once. You cannot have atomic composability regardless synchronous or asynchronous between rollups, because they don't share sequencer. And if you don't share sequencer, you cannot provably compose these calls regardless asynchronous or synchronous. And then synchronous atomic composability is essentially an end game, gold, like best price. It's a holy grail of our industry, meaning programmable blockchains, because when you have synchronous atomic composability between different rollups, between different blockchains, whatever, it means you can have endlessly calls between the systems which will be implemented simultaneously or fail simultaneously in all or nothing manner.
Yeah. So I think
I don't know. For me, synchronous and atomic is kind of synonymous. Okay, what is a asynchronous atomic? Okay, I don't understand.
It means when you can still make a calls, your transaction will be kind of included, but then if one of your transactions fail, then the whole thing will be reverted. Then the whole chain will be reverted.
Wait, so that's you're defining two things.
After some time, it's like on the front end you compose several calls to different APIs, and then you get this requests back after some time, and then when they all return successfully, you say, okay, I implemented atomic this whole cascade series of calls in atomic manner. But if one of them failed after several minutes, or seconds or whatever, depends on your timeout, depends on your properties, then you roll back the whole thing and say this thing never happened. This atomic transaction didn't happen.
Yes,
so that's what's so it can be asynchronous atomic.
Right.
Synchronous atomic. There is no 100% strict requirement for that. But when people speak about synchronous atomic composability, they normally mean under 1 second execution time.
Execution, yeah. Not settlement, just execution, right?
Let's not go into this.
I think we are going to touch upon that. I don't think we'll do a lot of deep diving.
Because if we start discussing, for example, pre-confirmations on Ethereum and how these guarantees works, that it's kind of included but not fully settled, and then we throw also finality into this mix and start discussing if it's final, this thing, or if it's can revert it, and if it's considered final, it's like that's exactly what I meant, that we need at least several podcasts just to unwind this. But Denis' explanation is great. Like it's essentially, I think Flash loan is still a great example, and for multiple rollups, the holy grail would be to make something like Flash loan or whatever across different rollups, so you can bridge, swap, make some operation, swap back, bridge back, and all in the same all or nothing manner.
All or nothing manner, right? Like, guys. I think we actually jump straight into it, which is great because we are obviously talking to the blockchain enthusiast. But I wanted to quickly simplify two things here. What I wanted to do is really talk about the traditional TradFi world, right? Traditional finance, and then I want to jump into Ethereum with an example so that at least from holistically people understand what we are talking about here in case they are new to it, right? So in traditional finance today, right, like let's assume you have $100, I give you $100 and you want to buy equities, shares, right? Or even crypto, right? The process you go through, it sort of explains to you what composability means, not atomic, but composability, right? And guys, please correct me if I get it wrong somehow. So for me, composability means in a very simple way is you have $100, you go to a bank, you sign 100 documents, then you say, well, I now need to buy crypto, like you want to buy Kaspa, right? What do you do now, right? You have to then go to a on-ramp, right? You get to on-ramp. From there, you get to exchange. You have to sign up to on-ramp, separate service. Then from there, you get to exchange. You obviously sign up, do KYC. This is a perfect example of how things are not composable in traditional world, right? In this example, of course, there are examples that are like I think people give is hedge funds where you can buy part of hedge fund, but I don't want to get into it, right? Is this an example for people that are new to this?
It's kind of composable,
But
but humanly, manually
right.
composable. Yes, somebody goes and signs and pushes the paper here. Okay, yeah,
Yeah, yeah.
whatever.
I mean, this is a perfect example to show what non-composability looks like. It's not a composable environment. But blockchain, Ethereum, like when we discussing, right, it started to come up Ethereum. Ethereum layer one is composable as a whole, right? Like, yeah, it's not atomic composable, but it's composable because you can buy Ethereum, you can go then get into a Uniswap, swap to some other token, lock your token, stake your token, whatever you want to do. All of that is possible. But the example, I think, Dennis, you started with is very specific to that fragmented Ethereum ecosystem because of layer twos, right? And that's where the challenge really arises, where you start to look at, because of the centralized sequencer, now they're not talking to each other. So if a user A wants to take their funds from Arbitrum to Scroll, it's not going to happen easily, right? Because one of the examples that comes to my mind is zk-sync, right? zk-sync takes an hour, I believe, to do the settlement on the layer one. And then the layer one takes 13 minutes for the finality. So you're waiting for 1 hour, 13 minutes if you wanted to move one asset from one place to other layer twos, right? Why in 2025 this become a big a hot topic, atomic composability,
Yeah.
right? Why do you think that is the case? We have new blockchains like Sui. That's their big initiative. Their big focus is atomic composability.
Yeah, absolutely. The answer is very simple. Everybody is looking for a network effect in this industry. Currently, we kind of hit a ceiling. Like the L2s hit a ceiling in terms of adoption and retention. They want to grow, and the only way to grow is to connect between these islands, between the silos. Currently, our industry, like blockchain, programmable blockchain ecosystem is utterly fragmented. Like you have Base, Scroll, Sui, hundreds of other chains. Every chain has their own agenda and market and the demographic, which is fine. But then you need a way to communicate between those. It's like in Web2, you have infrastructure which allows you to communicate between different servers easily without even thinking how exactly you call this kind of API. Like you can call from Amazon, you can call to Google, from Google you can call to Netflix, whatever. It's all normal. Like we take it take it for granted. And it's almost instantaneous, right? So this communication, your email going through 20 hops without you even knowing it, but then it's got to your address even like in several seconds. So that's not the situation with Web3, unfortunately. We don't have a proper interoperability solution. Everybody has their own standard. So it's also not ideal because when every layer one or layer 1.5 build their own layer, we just end up with 20 different messaging layers between systems. So I think it's very healthy development. Like people understand that they cannot, if you want to grow, you need to communicate with other markets essentially. You cannot build in isolation.
I think that's such a good point you mentioned there, that we're not even talking about cross chain, right? In Ethereum case, we were just talking about cross layer twos that we're trying to solve, because that's a different issue, cross chain, how you talk to Ethereum versus Kaspa, right? that's a totally different challenge that you'll have to deal with.
You'll be surprised. You'll be surprised. Actually, if I think solving atomic composability is harder than solving communication with Ethereum. Essentially, if you have zero knowledge in place and if you settle on any zero knowledge compatible layer, you can have you can have bridges between the systems. But making them atomically composable and synchronous atomically, that's really hard.
That's what I meant. Yeah. So I think that's what I meant. Like composable, you already have, right? With wormholes today, right? Bridges exist, right? They are sort of centralized bridges. I mean, you can have your take on them with oracles, and it's a yeah.
Yeah, I wouldn't call it. I mean, this very, very subpar solutions. Everybody knows that it's a great, it's a colossal problem of the industry. Everybody knows that like, bridges exploits were super common several years ago.
Yeah.
It's kind of now it's partially fixed, but it's still one big point of vulnerability, unfortunately.
Yeah. Oh, 100%. It's the one I think I keep an eye on myself, and we do tell people that be careful of oracles and be careful of bridges, especially if they're canonical bridges. But let's perhaps bring this home now. Like, so we started with atomic composability as a wider topic for the industry. How does that matter to Kaspa, and especially Kaspa ecosystem, right? And it's a topic that I think Jonathan himself have talked about in the past, that the vision should be for Kaspa to build this ecosystem that's, is perhaps leading to atomic composability one day.
Yeah, Denis, you can kick off because I can tell about I can tell about specific solution, but Yonis' vision is bigger than technology.
Dennis, what is your big vision? Tell us your big vision here.
Because Kaspa, unlike Ethereum, decided not to put smart contract functionality, programmability functionality into the layer 1. Okay, it kind of goes from the beginning with a L2 solution. Okay, and there will be many L2s. Okay, and our Igra is just one of them. And even we as Igra will produce right after the CVM, we'll start making different L2s with more special purpose and stuff. Okay, so the question arises how to implement this interoperability between all these L2s, okay, in a synchronous manner, okay, in an atomic manner. And it kind of, first of all, because all the L2s on Kaspa are by design based, their transaction go through layer 1, it's kind of naturally synchronous, okay? Because there is because L1 is this synchronization layer in essence, okay? There is no separate activity happens on one L2, on two L2, and then they need somehow to reconcile their states, okay? No, it's already synchronized. But there are many questions arise how to make it work properly, okay? Because it turns out it's not very trivial.
There is a very well detailed vision for interoperability in Kaspa infrastructure. Like for all layer 2s based rollups on Kaspa blockDAG, they will be atomically composable. They should be atomically composable. And also the end game again is to have synchronous atomic composability between rollups on Kaspa. But the devil is in the details. It's a massive effort. I invite all listeners and viewers to check recent Michael Sutton's posts about that. He also created like very cool podcast, like AI generated podcast with questions and answers about this topic, and you will see how many interesting challenges this roadmap introduces. How exactly you connect these rollups together via shared sequencer? How you actually stitch this global state between different fragments, different logic zones of rollups? It's all this not a trivial task. But then again, if this will be solved, then any rollup which builds on Kaspa as a sequencer and just plugs into Kaspa as a sequencer can be synchronously, atomically composable with other rollups out of the box, and that's beautiful. But that's hard. It's really hard. When it comes to zero knowledge, it's
the thing is, okay, imagine like two zero knowledge rollups. Okay, let's say one Igra, one Kasplex, or whatever. Yes, and we want to make atomic transaction between them. in the transaction, there will be a function call into, for example, one of the Igra smart contracts functions. Okay, it gets the result, passes it to the second L2. Okay, and there this result is input to another function. Now, how the second L2 knows the current state of the variables of the first one. Okay, there is a sequencing commitment, zero knowledge sequencing commitments, which are posted by Igra from time to time to layer one. Okay, but they are not posted all the time. They can be delayed a bit by seconds or minutes or whatever. Yes. In the meantime, the verifiable state sits in the layer two node. Okay, you can get it there, but this second L2 then cannot rely on already computed state and committed state to L1. It needs to go take the whole Igra state, okay, and also compute its current state, okay, in addition to its own state, okay. So it's a huge burden on the second one. So how do we solve this problem, Dennis, for example? Yes,
Dennis, you're sorry to interrupt, but you are talking about zero knowledge proofs, right? Specifically. Yeah.
Yes.
So when Igra sends a zero knowledge proof for the layer one to verify, now how does let's assume this example, Casplex needs to go through the zero knowledge proof again?
No. If Igra already posted its sequencing commitment to L1, the other L2, let's say Casplex, can trust this one because it was verified by Kaspa layer one already, verified and committed to some Kaspa block. Okay, but if this commitment has not come yet, okay, because it can be delayed, okay, a bit. The other L2 is in trouble. It cannot blindly trust what's fed to it from other L2, which has no idea about. It needs to go in and somehow compute for itself the validity of the current state of that L2.
To put it simple, the flip side of this holy grail, when you compose several rollups together, and that essentially creates this interconnection, interoperability infrastructure. The flip side of it, unfortunately, is all rollups should be aware of what's going on other rollups. And for example, if you have a rollup, imagine you have a base rollup, right, which is quite big in terms of TVL, and then we have Denis rollup, his own private rollup, which he just want to use for his own thing, which is, I think, it's what should happen, by the way, in the future. I think everybody should, like, it's like a website. Like you want your rollup, you run it. It's your interface. You want to control it. You want to build your own standards around it. You just have to adhere to some interoperability standards. But then you have this tool of rollups, and then Base rollup. Base rollup. It's not the same, but it's kind of the same, right? So base rollup wants to call contract which is deployed on Denis rollup, and then the whole thing should be. They want this to be synchronously syncatomically composable. It's not like there should be some like very strict deadline for Denis rollup to respond. Because if it goes down, then the whole transaction, the whole cascade of calls, the whole composability thing will go down. So this is essentially a dependency, right? So this is again like in the real Web 2 world. When you have your API out there, you should actually make sure that you have kind of like SLA, like service level agreement, that your API is available. This is the standard. This is the format, and this what's good. It's a maturity. It's essentially like this industry. We should mature similar to Web 2. In Web 2, nobody actually questioned this. If you have publicly available, publicly faced API, your responsibility is to build it properly. According to this well-known 12 principles of developing production-ready software applications. So we should go for the same down the same road for Web 3 as well.
That's very meaningful, and it's it's also eye-opening a little bit for perhaps people that think it's here, we can have atomic composability here tomorrow on Kaspa. I think, that's why I thought it'll be good to discuss at least the high level.
Yeah, so you are correct in saying, I think, that how to say, this is a big roadmap, but public should not expect it to be available tomorrow. When, for example, Igra and Kaspex roll out their mainnet, I don't think we'll have a nice communication at first. Okay, so
So just moving on, I guess, let's move forward. I think we've covered quite a bit of atomic composability, synchronous, asynchronous. So I think it's a good start. Perhaps we will need to have more session and very detailed session on each topic. But just moving forward, let's talk about all the exciting stuff happening at Igra Labs. So where do we start? I think you have your testnet coming out, right? Mid July, you said, Caravel. So congrats on that. I'm sure it's stressful time for you guys.
It's crazy, but it's a good crazy. So we have, so of course, like we have development efforts. We want to kind of like freeze the code end of this week, so we can start testing it.
Okay.
And this, and polish it, so we can open it mid-July, as we mentioned. But watch the space for specific announcements. In parallel, we also we're making rounds with with our ecosystem, like the best people, like future developers which are going to deploy on Igra. Like these that's the best part of my day, because we discuss with people what they want to build, how exactly they can use unique properties of Igra. And of Kaspa, essentially. That's always invigorating to hear other people's plans, because it's kind of, it give us the purpose, right? If we just deploy infrastructure without projects on it, it doesn't make any sense. Like we want to have real users, and real users will come only if there will be real interesting applications and protocols deployed on Igra. So this is also a very important part. We're going to be end of this, like beginning of next week. We're going to be in Cannes, in ETHCC. I really like this conference. Like normally, many people coming from very diverse backgrounds, both builders and users. It means like we can explain blockDAG and Igra and everything we built to lots of people. I specifically invite viewers, if they around, they should come 1st of July. In the evening, they should come to Kaspa event. We're going to be there. So we're happy to connect with people, just have a drink, have a laugh. That's always important to have a real cases, like real conversations about, again, because we're building for real people. We're not building infrastructure in the vacuum. We want people to use it. In terms of testnet, for us, testnet itself is interesting thing, but we kind of did it already with DevNet. I think the most challenging part is about nodes. We want people to run our nodes, because that's essential part of what we're building. We explained it in our post about Caravel, but in short, decentralization and censorship resistant can be guaranteed only if community run our nodes and not just Igra Labs. That's a very important part of this release. We're going to give it to the wider audience. We have at least 5 different teams who wants to take our nodes for a drive, and we're very excited about that.
I want to get into the Caravel itself, like all the details that you highlighted on your post. So I want to get into that. But a question that actually popped up a couple of weeks ago, that why Igra is spending so much time at these ETH events, right? You guys have been to ETH Belgrade. Obviously, you're going to ETHCC now. So why Igra team is spending time at these Ethereum events?
It's not Igra. It's developers doing their job. Don't worry. They're not spending time on events unless they really want to. But the thing is, I'm a big believer in Ethereum ecosystem. There's still lots of brilliant people there. It's still the best programmable chain in terms of decentralization and security. And I think also with current leadership, they have lots of healthy changes. I personally want to be in touch with this ecosystem to cross-pollinate, explain our designs, start people thinking, because there are lots of very intellectually honest people in this ecosystem. And if you tell them about Kaspa blockDAG and how you can build different programmable blockchain ecosystem using it, they listen. They ask real questions, they research. That's the best thing can happen. In Kaspa community, there is one big area of development. We should have more researchers and people who look into stuff deeply, research it, attack it, and not just praise it, but also question it. Like, if you want to build something solid, you should question it daily. You should ask yourself 100%. A question: is it really a thing we want to build? And this is what we can learn from Ethereum ecosystem. Like, these people, they debate roadmaps, they debate approaches, technology ruthlessly. Even if they're friends, they know how to dissect things. And this what we should learn from this. Not not just to praise and promote something because it's shiny, but learn how to ruthlessly reason about systems and find problems before these problems became bigger issue, like, for example, in Bitcoin technology these days. Right. Yeah. Because of the lack of the healthy debate, the whole thing turned into the circus, and now we have it is what it is, unfortunately. So I think that Ethereum has it better. Like the atmosphere there is better. The intellectual climate and culture is better, and this is something. This is something I appreciate, and this is something I want to have for Kaspa ecosystem as well.
And I think, plus on top, you're evangelizing, right, as you put it, Kaspa within this very well developed, very sophisticated, ecosystem.
Evangelizing, bringing people, making them look at. Convincing them come and build on Igra. That comes without saying.
Thank you for clarification. Moving on to Caravel, I know we are limited with time, so let's quickly go through it. Releasing the node client, right? L1 to L2 Canonical Bridge, and a protocol for lighter node, right? And the fourth one is DAO. It's cool to hear like a layer 2 actually moving more into DAO. Not many people perhaps talk about DAO. So quickly, I want to go through each of them. Node client, what can you tell us about the node client, right? So it's going to be separate node that obviously people can run. You've obviously talked about it, right?
There is a client, you download it, you set up on your machine, but hopefully not. You maybe have some cloud service for that. You run it, and you can send L2 transactions to L1 using your own software.
Right. What about the reward mechanism?
Igra node by itself just allows you to read and write L2 transactions, right? So everyone can run it, make sure that their transactions are made it into the layer 1. So this is like the basic thing. And then we need community, so people will run these nodes and to ensure basically decentralization and censorship resistance. And everyone can recreate L2 state and verify its integrity. But there is still a problem with liveness and security. If you run your node, I cannot force you to run it forever, to run it with, as I mentioned before, service level agreement. Like, make sure that your uptime is good, that your software is updated, that you send and receive transactions and stuff like that. So this is why we incentivize the nodes, the node owners who wants to provide the proper service. So if you stake Igra token, you became a validator. So you're not just a node operator, you're a validator. And then you have power, but then you also have a responsibility. So you have the benefits of this. You receive portion of the fees which flow through the systems. You receive portion of iKas fees, wrapped Kaspa, gas fees, essentially. But then if you do not maintain your service properly, your server properly, then you will be penalized. Like, there will be full or partial slashing of your staking. Obviously, we need to allocate Igra token to the community, to our early backers. There will be several ways to do that. They will be allocated across basically major 3 pools: development ecosystem, the developers, community, and early supporters. Also, some portion of tokens will be reserved for the Igra Association, which is a pre-form of the DAO. So we plan to transition to DAO in the future. So if you support project now, you will be part of our early community. So, and participation program will be announced separately.
So I think, Pavel has explained to us there will be a rewarding mechanism. He's obviously talked about the token itself. So let's move on to the second point, which is the L1 to L2 Canonical Bridge, right? So that's basically for the iKas itself, right? That's the plan here, to have iKas canonically bridged to the Kaspa, right?
In a pure academic sense, people will object to call it canonical bridge, because for them, canonical bridge is only two-way. Okay, it's L1 to L2 and back. Okay, and we will not have L2 to L1 canonical bridge. Okay, until there is zero knowledge of code on the layer one. Okay, we call it colloquially canonical bridge, but academically it's just an entry of Kaspa into layer 2. Okay,
so that's the entry of Kaspa to iKas to layer 2, right?
Yeah, we'll have to implement or community. We don't know yet, but probably it's even better handled by third party, not us. How to implement the bridging back, okay? But it will not be trustless, okay? It will be kind of trust minimized, okay? Maybe multi-sig, whatever. Yes, but it's a temporary measure. But obviously it's required, okay? So there will be some mechanisms to move your Kaspa back, okay? Yes.
Oh, I see. Yeah. I see what you mean. I see. So you can, as a user, I can take my Kaspa, lock it with at the smart contract, convert it to iKas, but I can't take from iKas back to Kaspa.
Not in trustless way. No.
Not now. Not the Igra's canonical bridge.
You'll have to trust some third party for this operation. Okay, unfortunately for now, but it's a technological limitation for everybody. Okay, it's not Igra's problem. Okay,
and obviously iKas is a gas. It will be used as a gas token, and along with this, it's going to be used as the rewarding mechanism to the node operator. So it's got a lot of utility all of a sudden, right?
Basically, it's role in the rewards are coming from a participation in transaction fees. Okay.
Right.
The stakers get their proportion of the transaction fees, okay, right. And the transaction fees are in iKas, obviously, yes. So they earn in Kaspa, right?
Yeah. I think that's the part. Pavel clarified before that it's not because of consensus, so it's not the protocol itself; it's the fee mechanism.
Yes. I want to clarify. What he meant is that for people coming from Ethereum, let's say, they will naturally assume that if you stake a token,
exactly.
We use this word staking, yes. This staking is enforcing consensus. Okay, this is the consensus mechanism, in any proof of stake system. But we are not proof of stake. No. We are proof of work. Yes, and this staking is not to ensure consensus. Okay, it's only to incentivize running the nodes and guarantee the proportional earnings of the stakers from transaction fees. It's a different role. Okay, so yeah.
No, I think that's very clear what you just said, and I think it also reiterated on what Pavel said. So perhaps just moving on to the two last things that you guys mentioned on your Caravel post. So how the node client will be different from a lighter node? Is it the same thing or is it different?
Basically, light node does not execute. The full node, layer 2 node, it will have EVM execution thing. Okay, but if you don't want to do it, okay, if you want to have your node just so it's closer to you to send transactions, you don't participate in staking. You don't participate in execution of smart contracts. You don't want all that. You only want kind of proxy, okay, to read the L2 state, okay. So you don't need all this heavy thing, okay. You put a light node, okay, for this purpose.
Got it. And the fourth one perhaps is is the DAO side. I think I got excited when I saw DAO, which means obviously you're opening up to community to, to vote on proposals. That's how most DAOs work. So what can you share with us? Like, have you thought about it, or is it very early stages to perhaps discuss DAO?
It is early stage, but some things can be said. Okay, because first of all, we don't want. We as Igra, we are a development company. Okay, we invented this thing. Okay, we developed it, we put it to market, but we cannot be a centralized entity controlling the destiny of the whole network. Okay, it kind of defines the purpose. Okay, and for this we need some sort of community management. Okay, for first of all, for example, the majority of the tokens of Igra tokens, okay, will not be in at first distributed. Okay, they are locked. Okay, for the future, for pools, for additional development. So, for example, let's take additional development. Okay, we'll lock there, for example, I don't know, 20% or 30%. Don't remember. Okay, of all the token supply for this purpose. Okay. So who gets it? Okay, we as Igra even cannot invent, cannot think of all the things which are needed for the Igra ecosystem in the future. Some other teams will come and say, okay, we have this cool idea. Okay, we want it, but I need money to develop it. Okay, and so all the Igra community should decide whether to give these guys money or not. Okay, not we, not I. Okay, so this is. This is the purpose of this of the DAO. Okay.
I mean, it could be other things, right? Most projects that have DAOs, they will do on the proposals for new ideas, proposal for development. They will do things like fee structure, like how to charge for certain things.
Yes, yes. Well, for example, fee structure. Okay, at first we will set it. Okay, but then a system evolves. Okay, we cannot be gatekeepers. Okay, in the long run. Okay, so we're moving from the beginning to separate us from all these concerns and give it to other communities to decide. Yeah.
I mean, we can have an entire session on DAOs because DAOs are very peculiar, right? What is the quorum for a DAO, for example? So I think there's a lot of things that happens with DAOs, but I mean, it's amazing to see at least you guys are thinking and obviously moving towards that direction of getting community involved in this decision making. So I think that's it's a great start. So let me just quickly ask you one last question to wrap this up. Okay. So just wanted to know on Igra ecosystem itself, right? I know one of the posts you guys did a while back, I think maybe a month ago or a couple of weeks ago now, was that you have 34 builders that are actually building on Igra.
I think that people are waiting for testnet. Okay, I glanced what's happening and I see that the teams kind of checked their thing. Okay, so it's working. But now next step for them is to invite their own users to like Zilla, for example, did on Kaspa now. They need to invite hundreds, thousands of people, and we won't allow it on the current dev. So, but it should change in a couple of weeks when we release testnet. Okay, I am very, very excited. I'm anxious to see it finally released because this will be kind of test for us.